We have another exciting show for you today and an amazing guest. Welcome to the Tech and Space Leader Show, where we learn lessons from leaders of the next frontier. I am your host, Lisa Dreher, and I'm really excited to introduce our guest for today, Nathan Kuntz. He is the co-founder and CEO of Rendered.ai. Welcome to the show, Nathan.
Thanks so much, Lisa. It's a pleasure to be here.
Yeah, absolutely. Well, it's great to have you back. It's been about a year since you were last on the show, and I
Right.
understand a lot has happened in that year's time. Last time we spoke, we were talking all about what Rendered AI is doing related to synthetic data. So maybe we can just do a quick recap on sort of where we were a year ago, and then we'll jump into what's going on now.
Yeah, I mean, synthetic data continues to be a really critical element of building out artificial intelligence broadly. You hear in the world of agentic AI, which is everywhere, you hear a lot about the importance of multimodal models and the ability to bring AI into the physical world. And in doing that has everything to do with finding the data necessary to train it. And as we talked about a year ago, um, the access to data for, especially as you get outside of RGB, if you talk about X-ray simulation, infrared simulation, or infrared imagery, satellite imagery, these are things that you can't find on YouTube, and it's hard to find data sets that can be really used to train AI. And that's where synthetic data comes in. And all of that has remained true and become even more important. I think over the last year, we've seen major trends around security imaging. We've seen a lot of push in healthcare and the need to, especially elder care, and the need to address that. And then, of course, counter UAS and defense applications have continued to build, especially, interestingly, especially in Europe. Where you see a plethora of small businesses beginning to emerge in order to address the defense needs there.
Wow, that's great. Are there other, I guess, trends or emerging new things that you're seeing happening in terms of just the application of synthetic AI related to the aerospace industry?
Um, I think we could talk about the federal government for a long time, but I think there's probably better places to talk about that. Let's just say the federal government has been tricky to work with over the last year, and so we've been focused on emerging commercial markets, and some of what's happened is actually with the advent of agentic coding tools, the barrier to entry for building out computer vision models really dropped. And what that's done is it's pushed the bottleneck really even more to the data. You can ask ChatGPT to build out a computer vision model all you want, but you can't ask it to build out 2,000 X-ray images of exactly what various bags or weapons might look like.
Sure, sure. When you're looking at, I guess, the acceleration of innovation and improved performance that complex AI applications can, I guess, support, what do you see happening there?
Yeah, so this last year has really been about the build out of agentic AI. So using AI agents, and we've really taken that to heart and built out some core elements of our business to leverage that. We think fully and transparently. I think in a way that's world class. Um, so over the last year, I mean, at this time last year, we had already implemented some auto coding tools and some things that could help our customers build out applications on our platform. But what we did was we really built out more and more of the automation around that. So we started to adopt technologies like MCP servers, which some of your listeners may be aware of, but that's a standard way to provide tool calling for agents, and then a whole stack of cloud assets that would allow our engineers to build out synthetic data capabilities much more quickly. And in fact, it's completely changed the economics for us and in a very positive way for our customers. So where historically in a typical engagement, we would talk to a customer through their problem and maybe show them a few examples of things that we could do that were relevant to their specific need. And in this industry of synthetic data, all applications are very specific. People don't ask for generic things. They always have some, like, if they had a generic problem, there'd already be a data set for it. So the problems we get are the weird ones. And so just about every engagement is somewhat bespoke, and we try to pull things. But historically, what we would do is engage with them, understand the problem, and then we'd sort of propose the build out that they specifically needed to them for professional services. And we try to get that done really quickly. But it wasn't until you built that out, implemented it, built a data set, trained a model, and tested it that you'd really know whether or not it was working. And typically it would take some iteration and some time. Well, what's happened with Agentic AI is you can go through that process so quickly. And at Rendered.ai, we now have also, every day we build out more content. So we can go through that process so quickly that we've flipped the model on its head. So now if a customer brings a data set in and it says, hey, I've got 20 images that are examples of things that I'm trying to find, but it's not nearly enough to train on, right? That's far too small to train on. We will, on our own dime, and typically within about 2 weeks, build a data set for free, train a model, test it against theirs, and share the results. We don't share the data set, we share the results with them, proving the efficacy of synthetic data before they ever have to pay us a dime. And it first of all, that changes the economics. So it makes it much easier for our customers to adopt at low risk. But it really it changes the entire risk profile of the endeavor, right? So now, because we can build and execute so quickly, we can take that complete onus on ourselves, and that's been a real win for I think the industry.
Oh, wow, that's amazing. So what types of things have you learned as you've integrated Agentic AI into Render's approach?
Yeah, well, there's a lot to it. I mean, you hear. I mean, if anybody scrolling LinkedIn would think that agentic AI is all nonsense, based on the number of things that people run into. And it turns out, like any technology, you have to figure out how to use it. There's a lot more ways to use a technology incorrectly than there are ways to use a technology correctly, which is true for cars as well as agents. So I think we've learned a lot. One thing that we've seen is that we talk about automation, but none of these tools are full automation. You don't just press go and then come back 2 days later and it's done. But what they do is they take a task that would have taken an hour and they turn it into 10 minutes. But they also free you up for those 10 minutes. So the workflows that work best are ones where you define the work well, kind of kick an agent off, then move on to the next agent, and you can kind of stack them together so that you're working through 3 or 4, maybe 5 or 6 tasks at the same time, letting each one go and then coming back to it. And so there's still an iteration required, but you become much, much more efficient. And on top of that, you've got to really think about how you're going to handle large data sets, how are you going to share tools, how are you going to handle large amounts of compute. I mean, a lot of the things that are our bread and butter.
Yeah. What have you seen as the biggest, I guess, challenges or just roadblocks that you run into as you're going through this process?
The interesting challenge is it has become so cheap and fast to write code that you just have to think a lot more about how you're going to share it and distribute it, rather than, like, in a world in which maybe I'm going to write 100 lines of code, and if I'm a really good programmer, right, then I might commit that to GitHub, and that would be stored, and that'd be fine. In a world in which in a day I write 100,000 lines of code, it's like, well, the whole conversation moves to how are you testing that? How are you deploying that? How are you plugging that in? All of the other pieces of doing software engineering become really critical. And so we spent a lot of time thinking through that. And it turns out some of the tools that we've had for years just are valuable. They just become more important. So things like containerization, managing isolation of different tasks is all critical. I see.
Sure. Yeah.
We have a
Yeah.
question.
Oh, let me look. I was just going to.
Yeah,
Let's see. Yeah,
Julie,
go
we've
ahead.
deployed into classified environments, so we're familiar with that process. We are model agnostic in the sense that we really focus on providing data. We do provide some model training services on the platform for standard things like Detectron and YOLO. Um, but at the end of the day, what we provide is data sets and the ability to sort of tailor the annotations on those data sets within the platform. And so you can bring whatever model you want to. In fact, there's also there's an MCP server available to our clients, and so if they have an agent of their choice, they can use that to actually interact directly with the platform via those agents and train models as well. Excuse me.
Great, great. Yeah. So just, I guess, stepping back for a second, the question on that was just referencing training the model and then utilizing a specific model, and then about using that in restricted environments. So yeah, I don't know if
Yeah,
you have. Go ahead.
maybe one other comment is often the models are restricted, but the synthetic data itself isn't. So we have a lot of, less in the U.S. federal environment, but more in Europe, situations where, we're not anywhere near their restricted environments, but they can take our data sets in because the data sets are easy to make sure that they're clean, and they can train models on restricted environments or not, and then bring them in as they see fit.
Sure. Okay, great. What do you see as the most, I guess, promising aspect of leveraging agentic AI frameworks in deep tech engineering, for example?
Well, I think there's a lot. At the end of the day, what we're really doing is applying these agentic stacks to large scale simulation and 3D modeling. At the end of the day, but most of our environments are large scale 3D environments that we simulate, and that looks a lot like other types of engineering. So, at Chimeta, we did a lot of electromagnetic simulation, mechanical simulation, but same thing for circuit analysis, for lens design, et cetera. So I think that those are really similar. And I think today they're maybe underutilized. We see a lot of tools for writing code. And in my opinion, actually, for some time now, well before Agentic AI, a lot of good engineering looked like writing code, right? When we were designing antennas, we didn't just kind of push the pixels around the screen. We wrote code that designed the antennas, and that allowed you to do designs of experiments and things like that more quickly. Um, so I think it's been best practice to work in that way for some time. But what's happening now is you can tie the code, the design code, the simulation code, and other tools together really, really easily with agentic AI. And I think that that's actually a piece that a lot of people are missing when they talk about physical AI. We talk about physical AI sometimes. We talk about robotics, things like that. But actually, the whole design cycle is open for, I think, some pretty significant disruption with the use of agentic tools.
Excellent, excellent. So how have you seen, I guess, tech and space companies using AI agents in their R&D and operations initiatives?
Yeah, it's a good question, and maybe I should separate those tech and space as maybe two different things. Um, and I'll say, broadly, the time that I've spent, I was at Silicon Valley Space Week a couple weeks ago, and spent some time with folks in the space industry specifically, and I think the space industry is kind of behind, honestly. There were a lot of people talking about using cutting edge AI and referring to YOLO, and I was like, well, YOLO's on version 18. Like that's not cutting edge AI anymore. And so I think you have a bit of a gap also between, and I don't want to jump into a thorn patch here, but between kind of West Coast ways of thinking about engineering and other parts of the U.S. and maybe the world, where West Coast, I guess we're all early adopters. We're like, yeah, give me the latest and let me just do it. And I think most of the space industry is just a little bit more conservative than that, and also a lot of it is driven by government programs, frankly, U.S. or European, and so there's just a pace at which those change and adopt new technologies. So where you see the fastest adoption across tech is really those places which are more commercial focused. And I think where we're going to see the strongest innovation in is in these, like, let's say 5 to 50 person firms. And the reason is because, how I was saying before, you could kind of tee up these agents, and then you get a 5 to 10x speed up. It's going faster than you could, and you can stack 5 of them together. So with that together, a 10 person team, holy cow, the amount that is possible to do. Now you have to learn how to use the tools. You don't just sit down and like, you have to learn how to use the tools. You have to incorporate them into your workflow. But once you've done that, the amount that you can do, the pace at which you can do it, and the level of complexity that a small team can handle, the sorts of complex systems engineering that would be almost hard for like one person or a small group to hold in their brains, you can offload a lot of that. And so I think we're ripe for a massive amount of really exciting disruption. I think it's the small businesses focused commercially that are going to be the dominant winners, and I think then it'll eventually make its way over to defense.
Great, 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 great. So you've been in the space industry for a long time, and I'm
A
really
long
curious
time.
about what predictions you have about the technological advances that will happen as a result of using AI from an engineering perspective.
Well, I think the good news is that a lot of what has happened recently is we've driven down manufacturing costs, and we've driven down launch costs within the satellite industry, but we haven't really addressed design costs. And so I think now you're going to see design costs come down, and that's going to create overall economic benefits for smaller constellations. You don't need to design something once and then make 3,000 of them to amortize the engineering costs. So these smaller teams really mean that you're going to have more flexibility and less capital allocation required to do some of these, what historically would have been kind of mega projects.
Yeah, absolutely. It looks like we have another question that came in, and it's referring to, per your comment on Agentic AI never being fully automated, how do you prioritize and address the human in the loop interactions?
Oh man, that's such a great question. There's no one answer to that, but let me say this: the AI is only as good as the rules that you give it and the tools that you give it. So as these things improve, you still have to provide guidelines about how you want it to behave. Which it turns out, I feel like I've learned a lot about human management by AI management, because just the cycle time and the feedback is so much faster. But you're like, oh, that's right, I never told you that. So how could you possibly know? But at the same time, all the emotion is out of it. So you're like, oh yeah, no, I just have to tell you, and then you'll do it. So with AI, you really have to pay attention to what are called the rules. So all of these, you can think like the context that you provide are the rules if you're using things like Claude and ChatGPT. And so one of the things we did was we sort of separated out the rules stack. So there's rules for how AI should use certain tools. There's rules for how the AI should behave in your organization. There's maybe rules for how it should work with you, or things you wanted to know about you and your work preferences. And then if you're like in a workspace around a computer, there might be like, okay, on this computer, I want you to do this particular thing. I'm trying to address this task. So one of the things that you can do to really get a pretty significant efficiency boost is break those down and make it easy for you to bring the right rules and right context into the right environment. So that's one, rules, and then the other one, tools. And it's too bad that those rhyme. Wasn't intentional. But then agents, for the most part, there's times where you just want to have a nice conversation with AI, but most of the time you want it to do something, not just talk to you. And so you have to give it tools that it can use, and so those are things that it can call. And so, like, right, even internally, right, we have tools for HubSpot integration. So our marketing goes through, yeah, it's not clicking buttons on HubSpot anymore. It's asking our agents to do things for us. If we're doing a lot of engineering and design, I mean, those are all tools. We have a very complex synthetic data platform. So if we're building graphs for it, if we're building 3D models, if we're training algorithms for detection, those are all tools that we've built out. And what those tools enable it to do is sort of execute certain tasks consistently and with far more complexity than you'd be able to do otherwise. And so thinking through your rules and your tools is the critical piece. And then yeah, we typically let them run for a while with rules for when it should come back, and then you kind of have to keep an eye on it. I think the right mindset is to think about these agents as junior engineers, becoming increasingly more senior over time, maybe, but you sort of will, let them run and then make sure that they come back and explain to you what they did, and then tell them why they're wrong. and
Yep.
but it works. It could go very efficiently.
That's fantastic. Well, Nathan, I want to thank you so much for making time to be here today. If someone wanted to learn more about Rendered AI, what should they do?
Sure. So, feel free to ping us on LinkedIn or just come to our website. We'd love to hear from you. Also, feel free to look me up on LinkedIn. We'd be happy to chat.
Excellent, excellent. Well, thank you again for making time to be here today, and we look forward to seeing where Rendered AI is going to take things next.
Thanks so much, Lisa. It was my pleasure.
Absolutely. And I do want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, you can visit guideforce.com. And we'll see you next time on the Tech and Space Leaders Show.